Hey, everybody. Christina Mallon here. I lead inclusive design at Microsoft. And about a year ago, one of my colleagues and friends, Doug, messaged me and said, "You need to meet this guy, Pete. He is amazing, such a good designer." And I was blown away in my first conversation with Pete. We had such amazing, like, shared realities and experience. And, he has been in design a lot longer than I have and have learned so much from him this past year. Pete, is a user experience designer at Intel, specifically in the human-centered design lab, and doing incredible work that he's going to share with you today. So I'm going to talk a little less because I don't want to tell your entire story. So I'm going to hand it over to Pete. Pete, introduce yourself and let's get this party started.
All right, should I open up the deck and get
Yeah.
going? Gotcha. All right. Okay. All right. So I am going to walk you through the coevolution of two disabilities that I have, how each one of them have profoundly affected the way that I think and build my stories. A journey to build a career with the complexities of disability and accessibility. I'll talk about physical disability and the struggle it takes to manage them, non-apparent disabilities and the shame and stigma that resides within them, the next evolution that could possibly be in universal design, how becoming an advocate for whatever your passions are will also help you within your career journeys, and showcasing and talking about some of my work that I've done throughout my career, throughout this talk. So Stephen had a role in my disability from the very beginning. I broke my neck when I was 20 years old in 1988. That July 20th to be exact. That means I'm old. In September of that same year, A Brief History of Time, Stephen's first book came out. Shortly after this, my mom showed me a copy of it or pointed at the TV. I can't remember exactly how it went down, but I remember very clearly she pointing out Stephen and saying, "See, people in wheelchairs can do things." And this, at the time, was extremely uncommon to see people in wheelchairs on the street who had disabilities. I'll talk more about these disabilities and the stigma that resides with them more as we go along. But to illustrate Stephen's point here, all the hardware and cameras you see facing Stephen right here, we came there with a team of people and we had a mission to help Stephen speak faster. I have a whole nother side story about how I got involved in this project, but I don't even think I have time for what I've got on the slides today. But he needed to speak faster. And so we thought that by using some sort of camera system, because he was losing strength in his body. And so if we could use a camera system, we could then move the area of target on his face that he was using to control the system that he had to someplace else as his disease progressed. And so at the time, these high definition cameras were super expensive. The technology underneath them did not exist. We had to develop it. But all of that now can be obtained for free and open source in the product that we call ACAP. And this is just one example of that quote. And one of the things that I'm really proud about with this quote is the fact that not only did Stephen speak this quote, but it was something that he, myself, and his personal assistant collaborated on to write. And it was something that's been a lived experience of mine and something that me and my manager used to talk about frequently. And now I'm going to let Stephen talk about it.
If you don't recognize my voice, my name is Stephen Hawking. I am the guy who made Black Old School. I am here to talk about a topic very personal to me, how science and technology can help people with disabilities. I've lived my life on the edge, pushing the boundaries of not just science, but what my body can do. Medicine can't cure me, so I rely on technology. It lets me interface with the world, It propels me. It is how I'm speaking to you now. It is necessary for me to live. I'm Intel inside myself. In the Connected Wheelchair Project, a team of Intel interns and employees from the Internet of Things group have built a sensor suite on the Intel Galileo board and created an app to seamlessly interact and analyze the information. A wheelchair user can now monitor important information about their health, the status of their wheelchair, and the accessibility of the place that they visit, significantly improving their day-to-day life. This is a great example of how technology for the disabled is often a proving ground for the technology of the future. These technological achievements are due to the innovations and creative forces of developers like you. I challenge you all here to excel, to bring about the changes you want in the world. Keep pushing and never give up.
So Stephen, myself, and his personal assistant wrote that speech, and this was based off of some work some interns were doing at the time, and I was working with the interns. That speech was supposed to be delivered by Stephen in India, and it turns out that he got sick, and I ended up going and delivering that speech. That turned into another really great opportunity for me. The people who were putting that on was UNESCO, a branch of the UN, if you're not familiar with that. And UNESCO then invited me to go work in their Paris office, and I did that for a sabbatical for 3 months in around 2015, I believe. So that was really kind of amazing. The interns did a great job, and one of those interns started his own business in accessibility. Caligon is a seating company, and yet another example of that quote. That seating company that he started has an innovative technology utilizing some monitoring in a cushion so that it monitors the blood flow and offloads the pressure with air so that tissues aren't jeopardized, moving it around to different small compartments without actually moving the person in the chair. And it's changed people's lives. They can now sit when they have a pressure sore on their butt and not have to worry about it getting any worse. It'll actually begin to get better. This has gotten the attention of airlines and furniture companies, and he's beginning to roll it out in other ways. Adoption of new technologies is often very difficult, even though it does have promise. This is where the disability community comes in. It's not that we're out there looking for people to push these crazy ideas on. We've actually found that people with disabilities have a higher tolerance of getting into these issues than other people that don't, because the reward and the utility that they get out of something like this is so much higher, and they're willing to put in more effort to get to it. So this is something that I found pretty kind of interesting. This right here was the box. The Speech Plus is the box on the back of Stephen's chair that he used to speak with. Originally designed, and yet another example, for people who were blind to hear the written word, developed at Stanford and later in collaboration with MIT, they released it and released the Pros 2020 in 1993. There's a second version of this that was released at the same time. It was called the call text, which actually had POTS built into it, or if you're not as old as I am, POTS is plain old telephone system. These things were about $10,000 and were normally used, and not this particular version, but other versions, because Stephen went with the most exotic and the one that came from the geekiest people. But most of these things cost about $10,000, and they were used to read off the weather for most people. I mean, they were made for the blind, but most of the time they were used when you wanted to get the movie times when you called the movie theater. You wanted to hear the weather report or the bus schedule. It was how we got information before the internet. But there are other great examples of how technology is built for the disabled and then actually propagates. And one of my favorites of these is Alexander Graham Bell came to the U.S. as a teacher of the deaf convinced of the idea that electronic speech would help his mother in Canada, led him in, and so that later led him to invent the microphone. And then after that, the electronic speech machine, which was eventually rebranded as the telephone. Other examples include the automatic transmission, voice control, computers, voice to text, text to, I mean, they just go on and on and on. Go to the next slide. So now, universal design. When I started writing this speech, you might have even seen it in my bio. I was kind of almost thinking that universal design had been completed. And then the more I looked into it, the more I thought about it, and knowing the places that I've traveled, I can see where universal design hasn't been implemented yet. And I can see when universal design can be implemented in new ways, but only when we have it under a platform of activism or elevating it into the awareness of the public. So ramps, for instance, are a great way for anybody walking or moving their children in strollers, or somebody on a skateboard to move in the same area as a wheelchair. We take that for granted now. Curb cuts and easy access to buildings weren't always that way. Just in the last 30 years, we began to see that. And I've been in a chair for 36 years. So I know what it's like not to have ramps someplace. And those ramps weren't there because we didn't have the awareness. We need to build that into the consciousness of people. We do that through talking about it in activism. It's sort of the same way that we're dealing right now with pronouns. We're elevating that idea so that people will eventually hold on to them and begin to adopt those into their everyday. Second here to adjust my slide. All right. Now I'm going to talk about dyslexia. Is it a myth, a disease, or a gift? I had to jettison a bunch of information I had on this because I don't have enough time to go through it all. But the disease, what is it? An MRI, a person's brain who is dyslexic when they read is not dyslexic when they read. A small portion of the brain lights up, almost like an algorithm, processing the information, giving them the information almost instantly. A dyslexic's brain lights up all over, using about 80% more energy than the other person does. Those connections that light up, allowing people to read at great expense of energy and time, also make those connections when they're thinking about other things. Dyslexics have an ability to be great problem solvers, big thinkers. They have really great special awareness. They have all these tools that make them innovators. The government didn't see it that way, though. In 1978, when I'm 9 years old, this report sealed my fate. 101 years earlier, the first mention of word blindness came out. This report, though, said that there was no such thing as dyslexia, as a learning disability. And this was when I was 9 years old, and it was the same year they held me back a year instead of addressing the problem. Yes. Got somebody driving. Is it a myth, or it's been debated for nearly 100 years? So in 1918, Americans children were first required to go to school, and then you began to see a lot more of this, what they were calling word blindness. The first papers that were put out by Orton in 1925. The Orton Society was formed, which later became the International Dyslexia Society, came out in about 1950. And then the Word Blindness Center opened in 62. In 1978, the Warnock Report came out, kind of sealing my fate, telling my teachers were being told that he's lazy, he's not paying attention, he's not applying himself. My parents were really desperate. And so they began to look into what they could do to help me out. So they began to send me to eye doctors, and they had me staring at screens, at concentric circles. And this is where the myth comes in. Is it an actual myth? Because the reason why people are thinking that it is because the rich people or the middle class people, the people that had the money to send their children to eye doctors and specialists and psychologists were getting diagnosed with it. But the children that didn't have the money to do this weren't getting diagnosed, but they were still falling between the cracks. So before school was compulsory and we made standardized testing ubiquitous, dyslexics permeated all areas of society. Our scientists, our politicians, um, um, we had a lot of those dyslexics. Today we see them mostly in the arts and independent business leaders. If you look here and you look back through history at some of the people that were famously dyslexic, like George Washington, Albert Einstein, Thomas Edison, Leonardo da Vinci, F. Scott Fitzgerald, Yeats, Verne. These were all writers and scientists and politicians, but we don't really see those people as dyslexics anymore because we've actually sort of pushed them out. Now, um, if you look at what the population of dyslexics are today, and you think about the statistics about who are dyslexic, it's about 10% of society. Now, out of that 10%, you've got about half of the people that are in prisons are dyslexics, and half the people that commit suicides are dyslexics. So that gives you a really good idea about the stigma and how society values those people. But on the other hand, if they do manage to make it through the gauntlet, if they haven't killed themselves and they're not in prison, they still make up 35% of our entrepreneurs and roughly about 30% of our creative field. So this is the Intel Reader. I did the design work on this, but really the transformative part of this was the person who introduced it to me. His name was Ben Foss. He's also an author of the book that's here. He explained to me that what he was trying to create was something for the blind and the dyslexic, and that he created this because he was dyslexic, graduating from Stanford Law School. And one of the things I found super interesting about that was that when he was going through law school, he had all of his books read onto audio tape, and then he would play the audio tapes back at about 8 times speed. And he said that if he would have read them at the pace that he could read at, the speed he was able to read at, it would have been about 25 to 30 hours worth of reading a day. But at the speed he could listen to it, he could get it done in about 4 hours. And he could also do it when he was doing odd and weird jobs. So he took jobs mowing lawns, he took jobs being washing dishes, and he could listen to his textbooks. And he graduated from Stanford with a law degree. I was really ashamed about my dyslexia, and I never told anyone about my dyslexia. In fact, I had made it all the way through college without ever having told anyone that I was dyslexic. And the way that I did that was after I had broken my neck, I used my dyslexia or I used my quadriplegia to get the same advantages in school that I would have needed for the dyslexia. I had people that were giving me um, extra time on tests. I could speak out my answers on tests. I'd have people take notes for me in class. All of these accommodations I was getting for my quadriplegia, I was using for dyslexia because of that stigma that was built into it. Now, he pulled me out of my shell and I began to work on this project with him. But more than that, he introduced me to some of my friends that I'm still very close to today because we would get together once a year and go down to the Bay Area and hang out. These are entrepreneurs and business leaders and artists and actors, and some of them you probably know. But it was just kind of an amazing adventure sharing these cathartic events and talking through how we managed to get through school and the things we needed to do to get around our individual problems. And I'm featured in that book, by the way. Okay, now for the journey and the timeline for quadriplegia. In 1988, this was right at the forefront of the accessibility rights. So if you look back on this timeline in 1977, there was a sit-in, and there was 100 people with disabilities that sat in at I believe it was in California, but I can't be sure. It might have been in DC, led by Judith Hewen. And I think the accessibility conference that you guys put on every year was held up like a week last year because she passed away, unfortunately. So she's actually a really big name in the accessibility area. Anyway, this sit-in was after about a decade of laws that had been largely ignored, disability rights that people were promised but weren't getting, and so they wanted the acknowledgement of the American people, and this set it off. A whole bunch of people camped out in a state house, not letting anybody pull them out of there. They were quadriplegics and disabilities of all different kinds. But the next decade of the 80s saw building generation. They began to develop all of the tools that they needed to build out the ADA, which came to in 1990. And you can see here that I broke my neck a couple years earlier. By 1992, the ADA had been put into place. And then that was the same year that I moved out of my parents' house and into Myers Court, which I'll talk about in a couple minutes here. And then in 1992, the ADA became active as well. And then Judith Hewen, a year after that, became the head of rehab services for the federal government as well as special education. And that gave me the money and the opportunity to go to school for whatever I wanted to go to school for, and everything going to be paid for. Now, eventually, I did graduate. I my schooling was so terrible when I was growing up. It was I almost didn't graduate high school, so I needed to take um, high school over again pretty much. So I went to community college, then I went on to a state school and got my fine arts degree. Got that in 1998. By 1999, there was a new law that was put into place called the Ticket to Work program. The Ticket to Work program is a tool that allows people with disabilities like myself to still remain or still keep their aid care, but work. But it has a lot of limitations built into it. And this is something that I'm going to talk a little bit more about in a few slides. So what did it take for me to get through school and to get out of where I was at? How did my career, or how did I begin? Well, Myers Court is a really interesting organization in Portland, Oregon, and there's no other place like it anywhere else in the country. What it is just an apartment complex where a bunch of disabled people live. Those disabled people share their resources and they hire a staff so they can come in and help them out. It sounds like a nursing home, but the big difference here is everybody that lives there has their own apartment. This is not a communal space at all. They have a lock on their door and they can have people come and go as they want. They direct their own care. There is no centralized medication of any kind. There's no centralized anything except for the aid care. They just come down and help you out. It was a transitional place where people like myself could go learn how to be a quadriplegic, which sounds sort of weird, but from the other people that were there, you learned how to buy wheelchairs, what the best ones were, how to ride the bus, how to build the things you need. And that is one of the most critical things that people with disabilities do, is they're the makers, they're the builders. And so when I first moved in there in about 92, The only building that was around was the first one. Over the course of the 18 years that I did live there, they built out 4 more. Now we've got 5 buildings in the Portland area. Eventually, I moved out of there about 15 years ago. And in 2016, I joined the board of directors. And today I am the chairman of the board for this organization. And we're currently in the process of tearing down Myers Court. We're thinking about taking down Myers Court and rebuilding it, making it another headquarters for Quad and adding a lot more housing in that particular spot. We're also looking at doing some building in other places around Portland. So when I was living there towards the end of my school career, I started working for them. They didn't have I think that they did that just to kind of keep me under control because when I was in college, I had grabbed a whole bunch of coaxial cable, and on my time to get help from the helpers, I drilled holes in the walls and wired everyone's apartment together so we'd have our own network and we could have LAN parties there. And so eventually I became the network administrator for that building and then for all the others. Then I started doing their design work. I actually am responsible for that logo, so I apologize for that. And then I started working for a company while I was working there, or while I was living there, called Reinvented. And when I was working for them, they gave me a piece of technology when I first started school called um, Dragon Speech. And Dragon Speech, you can see up there in the top corner. Again, yet another example of the proving ground for technologies. This was the product that preceded Siri and Dragon Dictate systems, all of those. And it was about 80% accurate at the time. And if you know anything about speech recognition, I think you need to be plus 99% to make the average person use it. But for me, it was the way that I could interface with the computer. And so I was willing to put in the time. I eventually also worked at a few other places while living there. And now I'm going to switch over to my career, talk some about that, and then hopefully we'll have some time for some questions. So from the visual design, from visual designer to interaction to designer to user experience designer, the terms keep changing over the years as they always have done. But really, if you're a designer, it's all about empathy. Just like other labels, design has its disciplines, but in the end, mostly about its understanding who you're building for. I'm going to talk a little bit more about my work, and this is just to scratch the surface of the stuff I've done. I work in the labs at Intel. This is where we do the research and the development. As a designer, I have access to all these technologies as they're being developed. This gives me the opportunity to bring in ideas from many different kinds of research areas, from audio to vision to neuro to silicon to large language models. It just keeps going on and on. If there's a technology area in development, it's going to be going on somewhere in the labs. So when I'm thinking about how to solve a particular idea, or if I can look into these research agendas and begin to pull in some of these ideas that develop, then I can begin to bring those together and create stories and solve individual problems for people or for groups. So one of the very first things that I did in my career when I was that got me any kind of recognition was this particular tool. Um, it was well, first I'll start with the thing that's up at the top. The small product in the right corner is the digital health guide. The health guide was a monitoring system for health status and communication with healthcare services. But when those healthcare services were looking at the data that they were getting, they had to look at large volumes of data coming in from a lot of different people, and they were, sifting through it, and they were getting charts and they were getting numbers, and they weren't really processing the information. Well, I had I had a surgery that I needed to do, and I was going to be out for a few months. And my manager said, I want you to fully recover, but in the back of your head when you're recovering, think about data. Well, I did. I was thinking about data the entire time, and I watched a TED talk on biomimicry, and that sort of kind of got the juices going. And then I started thinking about color and data and how to portray that data in biomimicry. And I came up with this tool that we actually used, and we were able to filter through the data that was coming in from that digital health system, and it really helped the people who were actually examining it from a high level look over a great number of patients and say, oh, I can see where there are problems with that one patient based off of the colors and the shape that's going on. So this is how I got a little bit of recognition right out of the gate, which kind of began me moving in the direction towards meeting Stephen, which was just a few months after that. Whew, man, talking that much would take your breath away. Okay, so emotional understanding. Using sensors of all types, like heart rate monitors, cameras, sentiment analysis on your phone and on your computer, um, uh, and anything that we could monitor. We had cameras in your car. We were doing the heart rate. We conducted a longitudinal study, and every time we were noticing somebody that was having some sort of emotional event, or if they decided they wanted to have an emotional event, what we were trying to get them to do was annotate every time they do that. So if we could correlate the sensing that we were doing with the emotions that they were having, that they were reporting having, then we might at some time be able to translate or give the power of your computer the understanding of knowing how you're emoting, how you are emoting. And so if that's something that we can do at some point, it could be extremely powerful for technologies in the future. This is still something we're working on. People have been thinking about it for decades, and I'm not sure if it'll ever become, well, but it's definitely a very interesting. It was a fun process. So here's another one, and I'm just going to show you some very rough prototypes here, so you kind of get an understanding of some of the stuff that goes on from the beginning to the end. So some of this stuff is product, some of this stuff, and most of the stuff I work on is just research based. So, how can you communicate emotion over distance through touch? What might it mean to have a physical connection with somebody who isn't there? We ran multiple studies on what it felt like to have haptics being transmitted in different parts of your body. We looked at different ways of sending those haptics. And then we began to run more studies to see how we could, and this is the rudimentary one. We had actually had this all compartmentalized down into a nice, simple wearable device. But I just kind of like this picture. But the um, the um, the technology allowed people to communicate over distance and say, or not say anything, but to actually touch as a communication. I got pulled into this project a few years ago, and it was what kind of brought me back into the accessibility realm. I kind of always been working on the Stephen project, but not a whole lot, just purely on accessibility. But this project was sort of interesting. So we were trying to come up with a solution for helping people direct that were blind through different spaces. And there are some companies out there that are doing it, and we're actually working with one of them. But before we started working with those companies, we began to explore different ideas. And one of those things was, how do you do obstacle avoidance? Like the thing that people use canes for or dogs for. We thought, oh, you know what? There's LiDAR built into the phone. We started messing around with it. We came up with this particular idea, which actually It's not unique. This idea exists out in the world already, but we came up with our own solution for it because we wanted to add what you see on the right there, which is Braille. But imagine holding up your phone, and on the back of your phone there are haptic motors. The haptic motors then translate a simple grid onto the back of your fingers. Now that grid, if you look above that, you can see the dots that are on that picture, and you can see that the red areas are vibrating on the fingers there. That allows the person to understand where obstacles are and be able to avoid those obstacles. On the other side, on the other hand, where it says Braille, if somebody was scrolling through text, they would be able to read the Braille on the back of their hand instead of having to have it printed out. So we were kind of playing around with this idea. What we found out when we showed this to people were they were like very excited about the Braille option, but now there's some other Braille ways of doing it. It actually you can actually run your finger on your phone, I believe, and it will give you Braille. But the other one, the obstacle avoidance, blind, we neglected to actually ask the blind people, nothing without or nothing for us without us, I guess. But we should have started there. And when we showed that to them and asked, and they were like, "Well, we have a cane." We're like, "Well, this is better." And they're like, "Yeah, but then I have to hold my cane in my phone." And we're like, "Well, why wouldn't you give up your cane?" Well, my cane doesn't run out of batteries and it's always there and it's always leaning against the wall. I can't be without my cane. And so that very end, there's another thing about the cane. And also when you're holding up your phone and you're walking down the street, that's an indication of that you're blind. It gives other people the affordance to know that there's somebody coming towards you with some other problem. Now, another way that we started working with this company that is actually doing the wayfinding right now is that we help them to with some technologies to make it a little bit easier and a little bit cheaper to scan rooms. You can see that space that's up above there, which is an auditorium in the building that I work in, and that is a lidar generated image with about 3 million dots in it. And that was done by a robot. Now, if you run a robot through a space and it gives you a high definition visualization of that space, you can then port that information back to the user, who then can understand how to navigate to a particular spot. Now, that's a lot different than the obstacle avoidance, because this is actually directing them. It's saying, okay, turn left, go right, go straight. But there's also the 5-meter problem. There's the very end of the problem, or the very end, where when they get up to the last couple meters of the door, or when they're getting right up to the door, what number are they going to do? Where's the handle? Is there a doorbell to, all of these things? Where are the forks if I'm in a cafe? Another thing we were doing was working on how do you, in a noisy environment, when they use their ears to understand where they're at in space, how could you artificially help them understand? Now, if you think about that room that's right there, imagine it being full of people and you still needing to understand where you're at in there. If a person had headphones, you could use that LiDAR representation of the room, add an artificial ping into the room, removing all of the sounds of the people and just allowing them to hear the ping, which will give them spatial awareness of where they're at. Now, I'm going to pause for just a second and talk about a few of the technologies that I just mentioned. I just mentioned how you might be able to hear people or hear in a space. And what I've got there is I've got head-related transfer function. If you're not familiar with that term, the folds in a person's ear actually tell you in the distance between your two ears, combined with the folds in your ears, actually allow you to understand in space where the sound is coming from. So is it coming from the left, the right, in front of you, above you, below you, and so it gives you all of that information in that head related transfer function. Now, if you were to combine that with something like parallax camera technology, which is coming online right now, which is basically an array of cameras on one end and then an array of cameras on the other end. And when you move your body, you're actually kind of slightly moving your head between the cameras. And when you do that, you're getting the parallax view on the other end. So if you have parallax, that's more or less 3D. And then you have the head-related transfer function, so you can hear what's going on. Now, if you take those two things, combine that with the automatic touch that I was talking about earlier, now you've got a shared experience. Imagine somebody with a disability sitting down at the bottom of a hill that they can't climb, and the mountain climber climbing to the top of the hill and being able to show the parallax view, um, show or give the feeling of the experience through touch, and having the absolute spot on sounds that are coming from that space being translated down to the person who's down below. So you can actually begin to see how this technology will be able to help us communicate in new ways in the future. Okay. So ACAT, this is the software that we came up with for Stephen. Gosh, I'm running out of time here. So ACAT was originally designed for Stephen's affordances. And so we recently redesigned ACAT and re-released it in open source so that people could still be able to use it. It was really stuck in the 90s. It was looking like Stephen Hawking's technology still. And we wanted to update it and give it a fresh look, but we also wanted to add in a few other things. One of the things that we're super excited about that's coming out this year that hasn't been implemented yet, but I'm in the process of doing the design work and we're working out a lot of the bugs, is CRG. And that CRG is controllable response generation. And what that does is it allows context in speech, or allows context in the next word prediction and the sentence prediction. So imagine you're in a conversation with somebody who has a very difficult time speaking, like Stephen did, or somebody that is using switch-based scanning, and it takes a lot of effort for them to speak. If in the room there is a microphone, and that microphone's picking up on the speech and the content that's going on in the room, then that microphone can then translate that into large language models, compare it to the user's corpus or writing style, and then give suggestive text back to the user so they don't even have to write answers. It might just do it in context or give them pieces of things that they might want to say in context. And this switch-based scanning system is also we're also adding in one other thing, which is brain-computer interface. It's sort of the hot topic right now. You might see that that's happening in the news with Elon Musk company. He's got a hand in this right now, but that's kind of invasive. This is sort of the holy grail. If you can use your brain to control a computer system. So, but it is so incredibly difficult to do. Either you've got to put it in your brain, or you've got to put a gel cap on or a dry cap on, and then you have to train it every single time. These systems cost upwards of $10,000. But what we found was that there's a cheaper solution. There's an open source solution. And so what we've done is we've gotten that open source solution. We're testing it. We're building out the software that it needs to operate. We've created user guides for people to connect it themselves, and we give them a pathway inside of ACAT to actually use it. This software will allow them to use their brain to control it, and this is for the very tip of the top of the people that have disabilities where they can't speak. These are the people who have locked-in syndrome that absolutely can't move anything whatsoever, and so they're just stuck inside their own head. And as bad as that sounds, this is a way for them to communicate. And once again, the disabled community is pushing the ball forward for the rest of us. Can you imagine what it's going to be like in a few years when you can control your computer with thought? And then I got 2 more slides, and I'll take a couple questions. Now to close the loop on the activism piece of this. So just as an example, this the government, the state, just raised the amount that you can earn and still keep your healthcare benefits. Now, I'm lucky enough to have a pretty good job, and I've managed to go through the gauntlet before they started reducing the cost and examining it more stringently. But I would never be able to make it the position I have made it without having gotten hurt when I did. But if you look at this chart, it costs about $75,000 a year to take care of me, my physical disability, because I'm a quadriplegic. It takes a lot of work, but they will only allow me to earn about $68,000. There's absolutely no way somebody can jump the gap and get themselves independent with not being able to make enough money to pay for their own food and rent and car insurance and everything else, on top of the amount of care that they need. So if I did the math on this, it was going to cost about $119,000 for the state to take care of me, and if they pulled that, or if I wasn't working, and it costs them, they actually make money in taxes if I am working. So I'm going to go to the next slide. And to solve this problem, I worked with a few other gentlemen here in town, and we wrote a bill and put it into the legislation last year. There's only one other state in the country that has implemented this action, and that's Washington State. Oregon, unfortunately, part of our politicians did not show up to work. They wouldn't vote on anything, and so we weren't able to get it passed, but we're very hopeful that we can do it next time. And that's what I've got. Thank you.